welcome to Math Simplified. This video is for 9th standard students. Please subscribe and share with your friends. Today we are going to study rational numbers. In the previous video, I discussed in detail about rational numbers. Let us go through it once more. A rational number is a fraction indicating the quotient of two integers excluding division by 0. So it is denoted by capital Q. Q is equal to P upon Q such that P and Q are integers and Q is not equal to 0. So this is the general form of a rational number. It can be expressed as a decimal, which is either terminating decimal or non-terminating and recurring decimal. So this rational number, this fraction P upon Q, we can convert it into a decimal form. That decimal form can terminate or it may not terminate and it will be a recurring decimal. If the denominator of a rational expression can be expressed as 2 raised to m multiplied by 5 raised to n, then it is a terminating decimal. What does this mean? The denominator, the factors of the denominator, if you factorize it, should be 2 or 5 or both. Any other number is there as a factor, then it will not terminate. Okay. In a recurring decimal, the number of repeating decimals is called the length of the period of decimals. So example, this is a recurring decimal, 11 upon 3. When we convert it into decimal, it will be 3.666. So the recurring part, we will denote it with a dash over that number. It is getting repeated. And the number of digits which is getting repeated, that is the length of the period. Here only one digit is getting repeated, so the length is 1. Let us go to exercise 2.2. Question 1. Express the following rational numbers into decimal and state the kind of decimal expansion. 2 upon 7. So you know how to do the division. It is very simple. Follow the same method. Write 2 here, 7 here. So 2 we cannot divide by 7. So we are going to put a point, put a 0 and then do the division. Just follow the same method and then again you realize that you come to a remainder 2. So if you do further, again this whole thing is going to get repeated. And here again you will get 2, 8, 5, 7, 1, 4. So this 2 upon 7, when we convert it into decimal, we'll write like this and put a dash over the repeating part. So this is a non-terminating and a recurring decimal. Okay, number 2, minus 5, 3 upon 11. First, this is a mixed fraction, convert it into a normal fraction like this. Then do the division, simple division, and you will come to remainder 3. So here also we had 3 and now again we are getting 3. So this part is going to get repeated. So 2, 7 will be repeated again. So we are going to write this as minus 5.27 and put a bar over this. So this is non-terminating recurring. Number 3, 22 upon 3. So again do the division and here you come to 1. Here it was 1 and here again you are getting 1. So this part is going to repeat again and we put a bar over the repeating part. That is 3. Okay, so 22 upon 3 is 7.3 dash. It's non-terminating and recurring. These sums are very simple. If you just practice them, you have done it in lower classes. So you just need little practice, you will remember how to do them. Number 4, 3 to 7 upon 200. Again do the division. Here you are getting the remainder 0. So it's a terminating decimal. Express 1 upon 13 in decimal form. Find the length of the period. Again do the same kind of division. Again you are ending up with 1 remainder. You started with 1, here also 1. So this whole thing will repeat. So you are going to write 1 upon 13 is 0.076923. Put a dash over it. And the length of the period, count the digits. 1, 2, 3, 4, 5, 6. The answer is 6. Now question 3. Express the rational number 1 by 33 in recurring decimal by using the recurring decimal expansion of 1 by 11. So find the decimal expansion of 1 by 11. You will get 0.0909 like this. Then 1 upon 33 is equal to 1 upon 3 multiplied by 1 upon 11. So you got 1 upon 11, 1 upon 3 if you multiply, it will become like this. Now we are asked to find 71 upon 33. What is 71 upon 33? Convert it into mixed fraction. 2 5 upon 33. So 2 plus 5 upon 33. 2 plus 5 into 1 upon 33. You know what is 1 upon 33? It is this. So 5 into this number. If you multiply, you will get this. If you add both, you will get this number. And this is a recurring decimal. Put 2.15 and put a dash over it. Question 4. Express the following decimal expression into rational numbers. So now we are going to convert decimal into a fraction. Okay, so this is the recurring decimal they have given. So you just write let x is equal to this. Now the period of length is 2 digits. So you are going to multiply it by 100. So whenever you multiply a decimal with 100, there are 2 zeros. So this point will shift 2 digits to the right. So you have to shift the point from here, count 2 digits and put the point. So it becomes 100x becomes 24.2424 dot dot. Now when you subtract these two, you get 100x minus x, and this 24.2424 minus 0.2424. If you do the subtraction, this decimal part becomes 0 and you get you're left with only 24. So x is equal to 24 upon 99. Question 4. Express the following decimal expression into rational number 2.327 bar. So here there are 3 digits. So we are going to multiply it with 1000. So that this point will shift 3 digits to the right. So 1000x is equal to 2327.327327. Now subtract 1000x minus x, you will get 999x. This minus this, you will get 2325. So x is equal to 2325 upon 999. Next sum, minus 5.132. So this is there is no recurring part like this, so you don't need to do all this. Just simply write down the fraction. This is equal to minus 5132 upon 1000. So minus 1283 upon 250. You can reduce it or you can leave it as it is. Number 4, 3.17 bar. So let x is equal to 3.17. 10x will be, you shift the digit 1 digit here, 31.7. 100x means again here 2 digits. So it will become 317.7. Now you can see that these two have the decimal part you have to subtract to make it 0. So 100x minus 10x. So when you subtract, the decimal part will not be there, only the number will be left, 286. So 90x is equal to 286, x is equal to 286 upon 90. Number 5, 17.215 bar. The bar is over 15. So again find out x, 10x, 100x, 1000x. You can see 1000x and 10x, the decimal part is same. You are going to subtract this. So 1000x minus 10x. If you subtract, the decimal part will get subtracted and you will be left with 0 here. So you will get a number like this. So x is equal to 17043 upon 990. 6th sum, minus 21.2137 bar. So the bar is over only 7. So write down x is like this. 10x, 100x, 1000x, 10,000x you write. And you can see that in this last two only the decimal part is same. So I am going to do 10,000x minus 1000x. If you do the subtraction, the decimal part will become 0 and you will be left with a number like this. So x is equal to minus 190924 upon 9000. Okay, question 5. Without actual division, find which of the following rational numbers have terminating decimal exponential. So you are not supposed to do the division. So you just have to factorize the denominator. If you factorize it, you find that the factors can be written as 2 raised to 7. You can write it in this form, 2 raised to 7 multiplied by 5 raised to 0. So this is a terminating decimal expansion. 21 upon 15, reduce it, you will get 7 upon 5. You can write it as 7 upon 5 raised to 1 multiplied by 2 raised to 0. So it is a terminating decimal expansion. 4, 9 upon 35, convert it into a fraction, factorize the denominator. This is not a terminating expansion. Why? Because it is not in this form. You have this extra factor 7. So this is not in the standard form, therefore it is non-terminating. Number 4, 219 upon 2200. Factorize it. Here the denominator is 2 raised to 3 multiplied by 5 raised to 2 multiplied by 11 raised to 1. Again, this is not the standard form, so it is non-terminating decimal expansion. Here we come to the end of the exercise. Please go through the video once again. Pause the video on each sum and practice them.